For smartphone SoCs, there are 5 big players. You've got Apple, Qualcomm, Mediatek, Samsung, and Google. That's outside of China. Inside China, you've also got people like Huawei and Unisoc that used to be Spreadtrum. With a smartphone SoC, you have design targets. You've got to get it within a certain die area, a certain power, but this is actually where we're seeing a good deal of innovation. This phone is something that I've been carrying for the best part of a year now. And the reason why I chose it is because of the chip inside. The device is, pure Chinesium in a way. However, the benefits that the design has given me far outweigh some of the defects. Inside here is a Mediatek Dimensity 9300. It was the chip they announced last year, and the design of that processor breaks conventional norms of what a smartphone should be. Traditionally, a smartphone has 8 cores. This has just been the standard for quite a while now. Some companies have dabbled in 9 and 10, but 8 has been standard for a while. Companies typically separate that into 4 large high-performance cores and 4 small cores. This is where big.little, or what ARM now calls its dynamic architecture, comes from. Typically, those big cores are A700 series, A70 series, representing, the mainstream to peak version of cores, with the smaller cores, the efficient cores, being A500 or A50 series cores. In recent years, we've seen the advent of ARM's X core line from X1, X2, X3, X4, and a new one, X925. They renamed it to align everything with better across the stack. And a number of companies take those 4 A700 class cores and promote one of them to an X class. That provides the single core, the single thread performance needed for responsiveness on what are vastly becoming devices that we use every day more than anything else. So having that responsiveness is important. What Mediatek did differently in the Dimensity 9300 and what caused me to buy this phone is based on that scale of ARM cores. At the high end, you have performance. Your trade-off is that it consumes power and die area. It takes more space on the silicon. You go down to the 700 series cores, and it's slightly lower in performance across the frequency range, slightly lower in power, and slightly lower in die area. And then you have the A500 series. These back everything up by being the lowest power and the lowest performance, but their target is highest efficiency at a really, really tiny die area. And that's ultimately what they're used for. In any of these 4+4 designs or 1+3+4 designs, these A500 small series cores are backing up, providing background resources where latency doesn't matter, but things just have to be computed. What Mediatek did here in the Dimensity 9300 series phones is get rid of those A500 series cores, those effectively E cores at the bottom end. Instead, they went with a 4+4 design with 4 X-class cores, in that case 4 X4 cores, and 4 A720 cores. So completely eliminating the A500 series altogether. Now, why did they do this? Because when it was announced, I was thinking, that sounds like a laptop chip. And since then, we've seen things like Snapdragon X Elite come out with 12 high-performance cores. So I was thinking, well, they've removed the A500 series, so they've vastly increased the die area. What's that doing to the performance? I thought the A500 series were actually more efficient, especially at the frequencies they play at compared to the A700 series. I've tested it, and they're not. I'm going to show a graph here that's one of the industry standard tests called spec. Some people like it, some people don't. Take what you will. However, what you're seeing on this space is a graph of performance of each of the cores in all the smartphones I've tested versus the total power consumed in the entirety of those tests. So if you're consuming 11,000 joules of energy, then it will be on the graph at 11,000 joules at whatever performance. What we see here is obviously the high-end X cores from Qualcomm, from Mediatek, the A series, from Apple really shining in the super high performance, and they're spending some power to do that. What I want to focus here is more on where the A500 series class cores sit, which is more in the sort of bottom left of the graph, and we'll zoom into that section. What we have here is really efficient cores from Apple here in gray, showing that you can be high performance and super low power to do those tests. We also have a number of the A500 series class between A520, A510, A55, all these sort of low-end cores that have come into smartphone SoCs over the last few years. And what we see in that graph is that it takes a lot of power to get there, considerably more than Apple does, at a third of the performance. It's really quite impressive, just where you need that efficiency point for those small class cores to be. Now, on here, I've put in the A720 class, A700 series cores from Mediatek's Dimensity 9300. And the performance is outstanding, offering almost 3 times the performance compared to A500 series cores. And these are 2 GHz versus 2 GHz at less power. That means these mid-range cores go through work quicker and consume less power doing so, which really matters a lot if you're loading up your smartphone with a lot of background apps that are taking up memory that may update all your social media accounts that update in the background by turning on the wireless and communicating and getting that update cycle. In these phones, that matters a lot. Ultimately, that's what's draining a lot of battery. And we've been relying on those A500 series cores to do a lot of that heavy lifting, especially in the Android ecosystem. So after having tested this and seeing this new Mediatek core does, the chip does 4+4, and these A700 class are actually pretty good, I'm wondering, so why did they go down the route in the first place? The performance is great. The battery life and the power efficiency seems great. What's the trade-off? And the trade-off is die area. A standard smartphone SoC these days, in terms of square millimeters, is anywhere from, say, 90 to 105, maybe 110. The Dimensity 9300 is more pushing 125, 130. As a result, the chip is more expensive to make. Mediatek gets fewer chips per wafer from their partner TSMC, and as a result, that has to be diced, that has to be processed. They then sell it to an OEM at a margin, and the OEM passes that additional cost onto the end user. So for a $1,000 phone, for Mediatek's flagship SoC, it's costing me probably another $20 to $25 to buy that design. As an end user, all I care about really is the performance, battery life, and cost. And where that extra die area is hitting me is in the cost. It's not big enough to affect the design and the form factor of the smartphone, but it will hit in cost. The benefit of that is just simply, I've got more battery life. And now I have a smartphone that, if I used properly, would last more than a day. The fact that I don't use it properly and I consume too much content and leave a lot of stuff running means I still get a lot more than what my previous S21 Ultra or LG smartphones used to give me. And that was a really interesting proposition. So I went out and I tried to find a phone with this chip. Because Mediatek is so new to the high-end space, most of those phones are based in China. I managed to get a device that was actually in the UK at the time, so I didn't need to pay all the import fees. And I've been loving it ever since. And this is important because eventually things get updated. And we always wait for the new generation chips. And this is why I find it exciting, because Mediatek have now announced their next generation Dimensity 9400, which is the one up from this. It's taking the same design philosophy of the 9300 series, but just making it higher performance. The standard gen-on-gen updates we tend to expect from smartphone SoC vendors. It's using a TSMC N3 process, so using the very much latest. And what they're doing here is, instead of having a 4+4 design, it's a 1+3+4. The 3 and the 4 look identical to the previous chip. What they're changing is the 1. So instead of using 4 X4s, they're using 1 X925, so that's ARM's new high-performance Blackhawk IP design, with 3 X4s and then 4 A700 series. So you still have, the bigger die area for having an all-big core design, but it should maintain the power, performance, and efficiency that came with the old chip just now in N3, just now in 3 nanometer. It's coming up. We're now seeing 130 square millimeters roughly hit 30 billion transistors, which is quite impressive. It's running a big version of ARM's Mali GPU. In this case, it's an Immortalis G925. It has MediaTek's latest NPU. This is the AI engine. I believe it's their 8th generation NPU, the NPU 890. It also runs LPDDR5X memory up to 10,667 megatransfers per second. That's quite a lot. I don't think I've seen many smartphones, if any, quotes anything higher than that. I wonder if that's aspirational or whether that's going to be the default for every device that comes out with this chip. But it's going to be interesting to wait and see. This is all an ARM v9.2 device, and it comes with standard 5G modem, Rev 7, and a new 4 nanometer Wi-Fi Bluetooth combo. The impressive numbers here from MediaTek, we obviously don't have the device, so we can't confirm these, is that compared to the 9300, which again is a 4+4, it's offering 35% better single-core performance in Geekbench and 28% better performance in multi-core. Now, I've been tracking Geekbench numbers of smartphones for a while, and let me bring up the graph that shows you where the Geekbench numbers are, and I think you'd be quite surprised. So, all the yellow spots here are MediaTek, and they are going up in that sort of curve pattern. The purple spots here are Intel. I have to be selective about which Intel chips I use because the minute you put more than 8 cores on some of these chips, it just makes the scale of the graph go too high. What we have got is single-threaded on the x-axis and multi-threaded score on the y-axis. And you can see Apple going through A13, A14, A15, A16, going up in that way as well. And then also in there, the Qualcomm in orange. Next generation Snapdragon 8 Gen 4 should be coming out shortly, and we'll get some numbers on that. But what we're seeing here is Dimensity 9400 is absolutely smashing it on the top right. Intel's Lunar Lake, which is this Ultra 7 258V, is beating it in multi-thread score, but is worse in single-thread, whereas Apple's is matching it in multi-thread, but getting more single-thread performance. So the fact that MediaTek is using an off-the-shelf ARM core and enabling that design to put that performance way up and to the right, ahead of Apple's A17 Pro as well, that's really nice. I really like that. That if those numbers hold true, it's going to be a fun device to test. MediaTek, announced this device this week as I'm filming this. So they're talking about the GPU, 40% faster peak performance, 44% power savings. Benefits are going to 3 nanometer and then using ARM's latest graphics. The things like super resolution. They're claiming 31% better frame rates. And in Aztec Ruins in Vulkan, and then Manhattan is another 9%. What's going to be important here is frames per watt. So I'd like to get a device in to test. As always, right now we have to speak about AI. So they're talking about multimodal AI running on these devices. Still waiting. AI on smartphones is a bit weird because we've kind of already been using it for ages on the camera side. People are now trying to bring in generative use cases like language models and Stable Diffusion. And I wonder how useful that would be, to the end user. But they have this AI engine. They're going forward with this new word, the agentic AI. This is where you string models together, whether that's on device or in the cloud. So it's clear that they're thinking about it, and it has to be high performance. On terms of the multimedia side, it supports wide range of cameras and audio. Interesting thing here is 8K 60 10-bit AV1 decode. But also 180 hertz WQHD plus display support, and also trifold display support. We're starting to see folding phones come out with 3 displays now, so you need to support that. Modem side, updated for 4 carrier aggregation at 7 gigabits per second sub-6 performance, and then Wi-Fi 7 because MediaTek's one of the leading Wi-Fi 7 providers. All in all, it's an interesting chip. But there's one other thing that I haven't mentioned that actually really impresses me with what MediaTek's done with the design here. And that's because it was hidden in a single slide in a February 2024 presentation at a highly technical conference called ISSCC, Solid State Circuits. I'll bring up the the presentation here, it's literally listed a 4 nanometer 3.4 gigahertz tri-gear fully out of order ARM v9.2 CPU subsystem based 5G mobile SoC. This is a presentation about Dimensity 9300. They just haven't called it that because it's an engineering presentation, not a marketing presentation. And they go through a lot of the technologies, a lot of things, what I've told you here about going from 1+3+4 with the A500 series, going to all big cores with X4s and A720s in the 9300. And they've said here that the efficiency core provides a 68% power saving at the same frequency versus the A500 series cores. And that's what my data shows. My data shows roughly around the same number. So I'm with them on that. When I saw, this is one of the slide decks I saw that made me pay more closer attention to the 9300 device. So yeah, they're talking about generational performance here. I want to go down to where we speak about the level 1 SRAM. So as we know, cores have caches, and we have a level 1 cache and level 2 cache, and some new CPUs have a level 0 cache. The design of these caches matter, because ultimately that's where most of the data flows through before it even hits the compute engines. So any savings and design features you can do matter. Now, one of the things that L1 cache needs is capacity. The more L1 cache you have, the better, the more data you can fit in at a lower latency closer to the execution ports of the core. So you want it to be big. The thing is, if you make it big, you also want to make it high density, which means using the smallest SRAM cells you can get. And most people in this case use SRAM cells that use 6 transistors. And that's kind of the industry standard because that helps with density. What Mediatek have done here, and what obviously the ARM IP allows you to do, is decide, do you want 6 transistor SRAM cells or do you want something else? Mediatek have gone with something else. And this is something I wasn't expecting. There are 6 transistor cells, there are 8 transistor cells. Turns out there are also 12 transistor cells. And what using more transistors does is it decreases the density, so you have less space for SRAM, but that's okay, you're moving to a new process node. That's what that affords you. However, because you don't need to rely on the switching capacitance of an individual transistor in that design, it actually helps with the power consumption long term across the whole SRAM cell design. And the slide they've got here, I'll put it, it's slide 18, it's quite significant. The power benefits of using a 12 transistor versus a 6 transistor based SRAM cell: a 73% reduction in read energy, a 51% reduction in write energy, and a 60% reduction in power for typical workloads. That's on the L1 cache, the most used cache in the core. You're saving 60% power in typical workloads. And they've said here, the overall result is 4.6% reduction in total CPU power for typical workloads. Now you might think, oh, okay, 4.6%, that's not a lot. But it's the tiny things that matter. And in CPU design, it's almost death by 1,000 cuts, right? If you can save, if you lose 1% here and 1% there, 1% there, 1% there, 1% there, suddenly your chip consumes twice as much power. So going from 6 transistor memory to 12 transistor memory has enabled Mediatek to pivot against industry standards, industry standard being 6 transistor, for just 4.6% reduction in total CPU power, or 60% power reduction in that L1. Now again, you got the trade-off, right? Does this mean you're having to go out to the L2 cache more and that's consuming more power? They've said the 60% reduction in power for typical workloads on the L1 and the needs to access more L2 overall has a 4.6% reduction in total CPU power, and that's why they've done it. Why wasn't this part of Mediatek's messaging when they launched the chip? Because nobody in PR knows that this exists. Engineering does this because, yes, this makes a better product, but nobody in engineering thinks, oh, this is an interesting story people want to hear about. I want to hear about this stuff. This is insane. Well, it's not insane, but it's these sorts of ideas that showcase that you have a company that cares down at the individual level why this matters. And the fact that they can put it into a technical conference showcases they know it matters. Unfortunately, companies like this, Mediatek's not unique in this, even the biggest companies that I deal with, the marketing, the PR, the AR, The comms sometimes don't ever know what's being presented at these conferences or what can make a story, especially for channels like this and the audience that we have here on the channel. This is great. This is what led me to buy this chip. This is what makes me excited for the next chip down the line, going from 4 nanometer to 3 nanometer. More transistors. I think they said they're going from about 22 billion to 29 billion. Better power reduction, higher performance. If those Geekbench numbers pan out, that's great. If I can do the spec power tests like you've shown, that's going to be great. I do need to see what's happening on the graphics side and see what's changing there. But I'm looking forward to it. And if it means a better product at the end of the day, banger. Now we just need it to come to Europe and to the US. Mediatek has said that the 9400 is coming to a wider market. I'll show you the back end of the slide here, because so this is the Oppo Find X7. The event where they're announcing this 9400, the next gen chip, was actually in London, showcasing that Oppo and Mediatek are having that strong partnership, and they will be the first to have the 9400 device in the market, in the global market, in due course, with the Oppo Find X7. I have put in my request for a sample, because I went out and bought this with my own money on the back of that presentation, on the back of the numbers that I'd found. Because I'm actually in the PC World studio here right now. I was on the PC podcast yesterday, and people said what innovation needs to happen in the industry. Sometimes, the things that people are optimizing for in chips don't matter to the end user, and die size is one of them. For the sake of $25, I have a better smartphone than I've had in the last 4 years, and that's saying something. Well, that's me done. I've wanted to actually do this video for a long time about the 9300, and the fact that 9400's come out is pretty nifty. I want to get some testing in, so yeah, if anyone from Mediatek or Oppo is listening, send me a device, because this is really important. I really like what you guys have done here. If you like this content, there are multiple ways to support the channel. You can like and subscribe this video, and many thanks for doing so. There's also Patreon, which gives you access to our Discord. There's a merchandise store and a newsletter, links in the description. For all of you who do contribute, thank you. You are keeping me well fed.